thank you very much. I hope I have the right clicker. We'll find out. So where do you go from this previous presentation? That was about as cool as it gets, and hopefully we can get just half as cool, and I'll be happy once I leave this stage. But it's really relevant to my speech and what we're talking about, and I like the concept of the everyman. I'll steal that from you and use it, because that was really the quest that we've been on. Hopefully that'll be clear when I'm done. I think Maus very elegantly captured where my starting point, I wanted to start not why I'm excited about simulation, but what I'm excited about what simulation can do, which is create these cars of the future or whatever product it is. We've been in a world, and I sort of started in the digital world, if you want, where the last 40 years or so, we've really been on almost like a pure digital revolution. It's given us Google, it's given us Netflix, it's given us internet banking, all these pure virtual. But the thing that's really exciting right now is that with additive manufacturing, with composite materials, with the Internet of Things, with AI, those things are melding together. And it is probably the most exciting time ever to be someone who produces a physical thing. Not just a purely virtual thing, but a physical thing. And that physical thing can be a car, an airplane, or it can be like Nebbia, who produces a shower head that uses about 20% of the water, right, that a normal shower head uses. So it's everything from two people in a garage thinking about how do I reimagine my shower experience, all the way over to what we just saw so brilliantly in terms of cars that fly through the air. But all of that does come with a cost, right? The cost is complexity. As an engineer, I have many, many, many more choices than I had before. It's not just, hey, is this aluminum or is it cast metal? It can be all sorts of composite materials that can be glued together in different orientations. I now need to take something like a pump that might have been a classic mechanical device yesterday, and I now have 5 chips on it and 7 wireless antennas that are all radiating. They live in an environment where everything else is wireless communicating. So, by the way, how do I get out of this interference nightmare where the signal that I'm coming back to me might not be what I was expecting to come out of that? So the poor engineer has to make a ton of design choices that they didn't have to do before. So opportunity comes with that cost, right? The cost is complexity. And how do we tame that? I mean, call me biased, but obviously we think simulation is one part of that tool chain that can help tame the complexity. We simply cannot, and I think Maus touched on this, we cannot build and break our way into the innovation anymore. There are too many choices. There are too many things we need to build and break. Our only opportunity is to take that, build a full digital prototype of whatever we're doing, and examine the thousands, tens of thousands of design choices. And then maybe we'll build a couple of prototypes. I certainly would hope that you build a couple of physical prototypes before you go driving and put your drivers in the car. But instead of building 500, we might now be able to digitally simulate 10,000 different prototypes, build a couple, test that it really holds out, and go to market. And that's why when you ask engineers about what technology they think will profoundly change their product development process, simulation sits up there next to 3D printing and so on. But historically, simulation has been not for the everyman. It's been something for the high-end specialists. It's been something where you typically spend maybe even a decade learning the physics, the numerical methods, the tools, the engineering. It's run on supercomputers. It's not uncommon for a simulation to take weeks to set up and weeks to run to get sort of just one result from one simulation. As a result, it gets used mainly towards today at the end of the design process, right? You've already made hundreds, if not thousands, of design choices. And in fact, when you look at those design choices, the majority of your concept is already locked in once you start simulating. You're just not aware of it. You've made all these subconscious choices before you get into it. What can we do to change that? What can we do to go from a place where simulation does take weeks to run? It sort of only captures like the mechanical or the fluid. It's typically one discipline at a time. And therefore, because of that cost, it's mainly used for very, very highly engineered products, right? If I look at our customer set today, they build jet engines or generators for power plants or cars, but very few of them are like Nebbia I mentioned that build $100 or $50 shower head. because the cost of the complexity of using simulation is too hard. So that was the quest that we set out at Ansys to say, hey, we are sort of the, we live and breathe simulation. That's our domain. We love it. But how can we make it such that it's accessible to the everyman? How can we, oh, did I go one too far? Or am I missing a slide here? Let's see. Here we go. Yeah, missing a slide. Never mind, I'll talk to it. How do we go from, if I can get back, how do we go from this space where it takes weeks? If I'm to make all the choices that I'm sure was part of designing a car, if every time I have to run a simulation we're talking hours, days, weeks, I'm simply not going to do it. So could we make simulation real time so that the instant you ask the question, you get the answer? And then you can iterate your way through it. Can we make it easy to use so that you don't have to be a specialist in esoteric turbulence models and when this numerical model fails versus that numerical model? Because you have a dream, right? You want to create a new car. You don't want to spend a decade figuring out which numerical method is the right. You just want to use the tool. Can we take the expertise? That's what we're good at, right? We love those numerical models, but we shouldn't put them out in a form so that everyone else should know the same thing just to be able to use them. Can we make it radically more simple to use? And that's what we've just put out, a technology preview. We call this Product Discovery Live. Hopefully it'll be obvious why we chose this name once I've shown it to you, which is the first real-time, interactive, easy-to-use simulation, 3D simulation tool. And instead of just talking about it, let me just show you the actual product. And before I roll the video, let me just say that what you're seeing now is not running in some supercomputing cluster. There is no pre-computation. It runs on a sort of ordinary laptop or desktop like the HP commercials we saw that you can put on your desk and you can run it real time. So here we go. Here it is. This is what it looks like when you open up Ansys Discovery Live. And all that you need to get started is to import your geometry from somewhere, from a CAD tool somewhere else, do a couple of very simple boundary conditions, water flowing in, water flowing out. And as soon as you let it go of the mouse, the simulation is running full 3D, real time. And it's interactive. You can go change the physics. You can go over and say, let me change this flow to a different speed, different direction. Instantly it updates. Here's what's happening, right? I changed the flow of the direction. Here's what's happening to my geometry. I can examine. It's not just the physics that are interactive, it's also the results. Let me take a look at the flow. What happens in different regions? I want to examine further. While the simulation is running real time, I can take a look and say, where's it stable? Where do I get chaos that I might need to get out of or change my design a little bit? And speaking of changing your design, it is not just the results and the physics, it's the geometry. So why don't I change it real time while the simulation is running and look at the impact, right? Change the geometry. Do something stupid. Let me throw something in the middle of this flow, something I'd probably never do before, right? But I can imagine it digitally. Why don't I just do it and see, oh, that's what happened to my flow. It started splitting. Oh, that looks good. Maybe I got a crazy idea that I never had before. Let's take a look at a different thing, right? Now let's go from fluids into structural. I'll fix these two surfaces. I'll put a force on the bottom. And again, instantly, I can look at the displacement. Okay, so this is what it does to my part. Here's how it deforms. What if I change the material? What if I say it's not aluminum, but it's something else? If I change the force, instantly you see what the choices are. Maybe, again, I want to, oh, what happened to our video and our screen? Did we go dead? Gentlemen? Both monitors are dead. There we go. Can you guys help me out so we don't have to go through the entire video again? Maybe not. Can you guys over there control it? No. Do we have to go through all of this again? Technology is wonderful when it works, but not so much when it doesn't. Okay. So not to drag you through all of this, again, let me just, while this is running, skip and say you can do all sorts of things with this tool. You'll see while I speak, we might get to where we design a heat sink. We start from scratch. We put a thermal load on it. We can actually throw a full car model into a wind tunnel in real time and take a look at it and say, what are the aerodynamics? No waiting. One of the great things that Justin, who is the product manager for this product, said that I think was pretty profound was, with traditional simulation, we're almost afraid of asking questions because it takes so long to set up. So you want to be pretty clear that you've asked all questions. One of the things where we think this changes things is that mistakes become cheap. So why not ask a stupid question? Why not say, as we talked about before, let me put this thing in the middle of the flow and see what it does? Because the cost is a simple click of undo, and I can do something else. So let's do that's why we chose that discovery name. Why don't we go and discover a broader set of things that we could ever do before? We now have the tools. This has been a radical breakthrough. We've worked with Intel and others to get this. This is about 1,000 times speed up of the traditional methods that you use for simulation. We rewrote the numerical methods. We rewrote a lot of the traditional algorithms to get this level of speed into the product. So now that you can take pretty much everything, this is a simple model. The end of the video was showing a full car assembly being thrown into that wind tunnel, taken straight out of CAD without any iterations whatsoever. And it's been exciting to see. As I said, we launched the technical preview of this last month. We're early, but we wanted to share our excitement before we had the product fully done. And it's been very exciting to see what customers have done with it and the excitement that's come out. There are just two quotes I'll pull out of this for you. One was, when you take a look at Jacobs Analytics, they are a small design firm. They are not a big Boeing or even Cummins. Right? It's a one-man company that does design. And he said, hey, in 15 minutes, I was up and I was running my first simulation, something I only dreamt about being able to do. Given that we're in a university, I'll take the other quote from Cornell, which was, I can now focus on teaching the topic and not the tool. So if I think back to me being a physicist, I would have loved when I had Mechanical 101 or Thermodynamics 101, if instead of just being limited to the stuff that I could solve analytically, which is a sort of very, very limited subset, those of you that are engineers will know that, if I could have had a tool like this and explored and coming out of school with a more intuitive understanding of the real world phenomena and how the equations play out in things that I would never be able to solve on a piece of paper with analytics. But I never did because it was too tough. This just flows straight into that educational flow. I want to leave you just with a customer example, sort of more pedestrian, but we're staying in the vehicle theme. Road Tech do these construction vehicles that help build highways, roads, and so on. This is a material transport vehicle. And one of the things they wanted to take a look at is, hey, when this truck transports it from point A to point B, what did the forces look like? Because that's important for them, right? Obviously, they don't want it to be ripped off, from behind the truck, and they'd want to save fuel and everything else. So they had this little canopy that you can see, trying to take a look at different angles and say, how does it flow? And typically, that's something that would take them a week to set up in a traditional, piece of simulation and run. But they could run this straight out of the gate, just, with the standard files in Discovery Live. And what they did, because they could now do it, was they got this crazy idea that said, what if I flip the direction of my vehicle? Instead of pointing that way as it's behind the truck, maybe I should turn it 180 degrees and see what happened. And guess what? The flow was much better. The forces were a lot less. They would never have done that before because that would have been a week's operation to get through that and get an understanding. But they could just, turn around, click it back into the model, and instantly see what happened. So for me, I think it's only left to say, what would you discover? You can go download the technical preview for free at our website. We're only at the early days of this journey. We'd love to get your feedback. We'd love to see what would happen if someone like Dyson, who built over 5,000 physical prototypes when he was reimagining the vacuum cleaner, what would have happened if he had a tool like this? What would he have dreamt of even more in terms of his vision? And if I sort of bastardize our friends, Sir Alexander Fleming, who discovered penicillin, maybe I'll say I hope that you discover both what you intended and maybe you'll learn some of the stuff that you did not intend and that, from the mistakes that you took. So thank you very much. Hopefully we inspired and hopefully we can be part of the tool chain that brings cars to life.